Greetings everyone, I am Syed Shahriar Islam Lamun. The title of our paper is Explainable Machine Learning for Understanding Trip Mode Choice Evidence from the 2022 United States National Household Travel Survey. Urban mobility today faces major challenges such as traffic congestion, environmental impacts, and unequal access. Prompting sustainable travel modes can help reducing environmental impacts and improve equity. Accurate prediction of trip mode choice is therefore critical for effective land use and transport planning. Traditional discrete models are interpretable but struggle with complex and non-linear data. However, machine learning models such as random forest, extreme gradient boosting, and k-nearest neighbor offers higher prediction accuracy but interpretability is limited. The objectives of our studies are evaluate random forest, extreme gradient boosting, and k-nearest neighbor for binary trip mode choice. Compare different terrain test speeds such as 70 by 30, 80 by 20, 90 by 10 using accuracy and area under the receiver operating characteristic curve. Apply Shapley additive explanation or SHAPE to interpret prediction and key drivers. Support data-driven, equitable transport planning using accurate and interpretable ML models. Traditional models such as multinomial logic, nested logic use socio-demographic factors but struggle with nonlinear relationships. Cluster and tour-based models offer insights but are limited in scope. Built environment and transit system performance influence mode and route choice. Machine learning models such as random forest extreme gradient boosting improve prediction but often lack interpretability and transparency. This figure presents the overall workflow of our study, from data preparation to model training, evaluation, and interpretation. For data preparation, we extracted household, trip, and vehicle datasets from 2022 National Household Travel Survey from United States Department of Transportation. For data preprocessing, we handled missing values and filter and clean null values. Then we merge those three datasets on house ID. In total, we considered 17 variables, 16 were used as input features, and target variable was trip mode choice. We classified this target into two categories: private transport as 0 and public transport as 1. The description of all features and the target are shown in this table. After feature and target selection, we split the dataset by different train test ratios such as 70 by 30, 80 by 20, 90 by 10, and then For each train test spilled, we train our dataset on selected models, which are random forest, support vector machine, and extreme gradient boosting. And after training, we predict and evaluate them. After evaluation, we compared models on accuracy and area under the receiver operating characteristic curve or AOC. Then we select best performing model based on AOC and accuracy. Then we interpret the best model using shape, and then we identify key feature contributions. Here we compare the performance of three machine learning models across different train test spells using accuracy and AUC as metrics. As we can see, random forest consistently outperformed the other models, AC being the highest accuracy and AUC. K nearest neighbor showed moderate performance while extreme gradient boosting performed comparatively lower. These results clearly indicate that a random forest is the most effective model for predicting travel mode choice in this dataset. This shape-B-sparm plot shows the key factors influencing public transport use. Younger individuals are more likely to use public transport, and residents of larger cities tend to rely on public transport more. Socioeconomic factors are also important. Lower education levels and lower household income favor public transport, while higher income shift preference toward private transport. Overall, this plot highlights how age, urban context, and socioeconomic status drive travel mode choice. On the other hand, for private transport use, we can see that older individuals are more likely to choose private transport, and households with more vehicles show a stronger preference for private modes. The presence of young children slightly discourages private transport use, suggesting that families often favor public transport for convenience and cost. Overall, this plot emphasizes how age, vehicle ownership, and family composition affect the choice of private transport. The key findings of our studies are random forest outperformed KNN and extreme gradient boosting across all fields. Younger, low-income individuals in larger cities favor public transport. Older, high-income individuals with more vehicles prefer private transport. Families with young children slightly favor public transport for convenience and cost. Socio-demographic factors slightly drive travel mode choice, supporting data-driven policy. For future work, we plan to integrate additional variables such as temporal patterns and multimodal transportation to improve model accuracy. We also aim to conduct longitudinal studies to better understand how travel mode choice evolve over time. These efforts will help support strategies for reducing urban congestion and promoting sustainable transportation. And finally, thank you everyone.